Hi, I'm Mike Roussos from the .NET Customer Success team, and today I'm going to talk about how .NET Core works under the hood. I've had some questions to explain just sort of how the product's put together, how it functions. So I thought the easiest way to answer that would be to just go through the files that comprise .NET Core and talk about what they do. This is probably a good approach because .NET Core is Xcopy deployable. If you look at the files that are installed when you install the .NET Core product, you've seen the whole product. So here I am in my .NET Core install in Explorer. You've got some different folders, most of which are not relevant to this conversation. You've got the top level .NET CLI, so you can call things like .NET Restore, .NET Run. And this is actually duplicated elsewhere more interestingly, and we'll get to that in a little bit. But this is just here, so that it can be on your path and you can use the CLI. You've got the SDK, which is your build tools, things like that. Which is not super relevant to the conversation of how the runtime itself works. So I'm going to jump into the shared folder. The Microsoft .NET Core app folder has the actual product installations. So we'll start here. There's a lot of files, but they fall into a few different buckets, so I think we can run through them fairly quickly. First, you have all of these API-DLLs. So these are all, in fact, if you mouse over them, they say they're stub DLLs. These are stub DLLs for API sets, which are changes in the way Win32 APIs are laid out in Windows, in a recent version of Windows. Now, I'm not a Windows expert, so I won't dive into the details of all this, but in Windows 10, in recent version of Windows, APIs have been moving from, say, for example, kernel 32 into, API MS WinCore, or something like that. And so these are just redirecting DLLs to make sure that native calls made by the .NET framework can find the right OS functions to call under the hood. So on different versions of Windows, these will be used to route different OS calls. So that's what all of these API set DLLs are about. There's a lot of them. Then we get into sort of the more interesting CLR bits. So you've got CLR JIT, Core CLR DLL. These are sort of the core of the runtime. This is the execution engine. This is all native. This is the native execution engine, JIT, garbage collector, loader, all of those just core fundamental pieces of the common language runtime. Core CLR, of course, is the .NET Core common language runtime. This is actually an evolution of the same small portable CLR that Microsoft created years ago for Silverlight, and it's now been updated and reimagined into the core of the .NET Core product, which is sort of cool. That's a little bit of the history of this alternate common language runtime, which is different than if you were to go look at CLR.dll or mscoreworks.dll in a .NET Framework install. These are the equivalent files. Or mscore JIT would be equivalent to CLR JIT. So that's kind of the core of the runtime. Now you've got these CoreHost and .NET.exe, which are actually very similar. In fact, I think at this point CoreHost is just a renamed .NET, and at some point we're going to pull some stuff out of CoreHost you don't need. These are the hosts. Now what's a host and why do you need a host? When you run a .NET Framework application, Windows doesn't know how to execute the MSIL bytecode, the intermediate language, the IL, directly. It needs to be JITted first. And so what happens is we actually, when you run a .NET Framework, a full .NET Framework app, what happens is we've got a little header in the PE file, which will spin up mscoreee.dll, which lives in Windows System 32. And that library knows how to start up the .NET runtime and the .NET framework. So when I double click on Hello World.exe that was built by .NET Framework 4.5, for example, what the OS actually does is it goes and it loads mscoreee.dll, and that component is responsible for starting up the runtime, starting the JIT, creating an initial app domain, loading managed code, and so on. Now, that works because the .NET Framework is an OS component and it has that tight integration with Windows. .NET Core does not have that. .NET Core runs on Linux, it runs on Mac, it runs completely decoupled on Windows from the OS itself, except for calling into some Win32 APIs. So when you try to run a .NET Core application, you don't get this built-in host that's part of the Windows product. So instead, you have this MSIL, you have this intermediate language, which needs to be JITted. And somehow, we need to start up the runtime to take care of things like that. So you actually need a native host. So that's what this is, CoreHost, .NET EXE. These are native Core CLR hosts. And sometime I can do a video on how to create a .NET host yourself if you want, so that you can run managed code from native code. But just know that these are native apps, which when you run them, they will start the CLR, they start the execution engine, they create an app domain, they load your managed code, they JIT your managed code, they start the garbage collector and the finalizer, and all those things, so that then your managed code's actually executing. So what that means is that when you build a .NET Core app, you're not actually compiling to an EXE. You may have noticed when you do a .NET build, you get a DLL, and that DLL needs to be executed by .NET. So you call .NET.exe and then your DLL, because the executable is the host, and your code lives in the DLL. You can actually see if you publish, here, I'll switch these around. If I look at the published output of a .NET app, a .NET Core app, so here's a .NET Core 1.1 app published for Windows 10. And so it creates, in this folder, an exe called temp.exe, which you might think is your app. But if you file compare against the .NET.exe, which exists in your NuGet package cache, you'll find that they're the same file. So when you do a .NET publish of a .NET Core app, the exe you actually get out, and this is for a self-contained app, of course, the exe you get out of publishing a self-contained .NET Core app is actually just a renamed .NET.exe, and that's your host. It's all native code. Your code actually lives in, that you wrote, my hello world or whatever this app was. It lives in a DLL, which is here. Now you don't need to do this if it's not a self-contained app or if you haven't published, because then we expect that you'll just use a .NET.exe that's installed machine-wide to do the hosting, and so you don't need to copy the host around. But that's what those are. Debug shim, of course, is to allow debugging. You got some libraries that support hosting. libuv is used for HTTP calls in the framework. You have some code analysis stuff. So this is getting into some of the Roslyn libraries that are available in .NET Framework. And now we're really just into the framework itself. So you've got some Roslyn stuff. You've got some language things like Microsoft Visual Basic, Microsoft C#. And then you start to get into these more framework libraries. Now, some of these are interesting. There's all of the system.whatevers. These are the facade assemblies which allow us to have built against the .NET Standard profile, or the .NET Core reference assemblies. So when we build a .NET Core app, you build against things. So when you compile, the compiler references assemblies like system.runtime, and it references assemblies like system.io, and these are common libraries defined as part of the .NET Standard, so that we can then use other .NET Standard libraries, and they all sort of point to the same libraries. But at runtime, we actually need to point back to the implementation. So you'll notice these are all fairly small files, and the reason they're fairly small is if I'll DASM this thing, what you'll discover is that there's not a lot in there. I'll bring this over here. System.io.dll. It's got some resources in it. So this is just for like getting resource strings for exception messages, things like that. But there's not a lot of APIs. Mostly what is in this assembly, if I look at the manifest, is a whole lot of forwarders to say, Oh, you're interested in memory stream? Go look at MS Core Lib. You're interested in stream reader? Go look at MS Core Lib. So it takes all of these different contract assemblies, and these are just what we call facades. A facade assembly is an assembly which is empty, but redirects calls with type forwarders to a different assembly where the implementation actually lives. So you've got all of these .NET Standard facades, so that when you use a .NET Standard library and it calls something in System.io, we say, oh yeah, we can handle that. Here's System.io, and we're just going to redirect that off to MS Core Lib. Now you may notice, though, that MS Core Lib itself is also small. So let's take a look at that. If we ILDASM MS Core Lib, it's actually similar. There's nothing in MS Core Lib either, except a lot of type forwarders, which forward things to system private core lib. So a year or two ago, we changed the design here so that instead of depending on MS Core Lib or the system.star assemblies, .NET Core would have its own implementation. That way it could consume libraries that depended on MS Core Lib or system.runtime. And it will forward all these to where the implementation actually lives. So this is another facade, which redirects to system.private.corelib, which, if we look here, you have the library itself as well as the .ni. Now, the .ni, if you see these in here, these are native images. So this is something that's been pre-compiled by a Core CLR version of Engine, so that it will execute faster. It doesn't have to JIT at startup. But if we just look at the library itself and we ILDASM this one, this is suddenly going to be a lot more interesting. So if we look in here, now we have all of the types that you would expect to be implemented for the .NET Core runtime. So, app domain, array, boolean, buffer, byte, console, whatever. And all of this implementation lives here in this library. So that's sort of how this is set up. So you've got most of your implementation here in System Private Core Lib, as well as some implementation in some of the other libraries. They're not all facades, but many of them are just facades which redirect to System Private Core Lib. Some other things that are maybe interesting I can point out, because these are all system libraries. There's also SOS and SOS Net Core. These are extensions for debugging. So when you're debugging from WinDBG or CoreDBG, you would use SOS as an extension to debug managed code instead of just native code. You also have MS Core DEC Core, which is another debugging component, which allows you to debug the managed code. And then beyond that, you've got some of these facades. You've got the MS Core Lib facade, of course. You've got some hosting libraries, and then you've got these API set stubs for interacting with Windows APIs. And that is what makes up the .NET Core product.